For decades, scientists assumed Pluto's atmosphere worked like a blanket, trapping heat the way it does on other hazy worlds. They were wrong, and in 2025, the James Webb Space Telescope proved it. Pluto is not cold because it has no choice. Pluto is cooling itself down, on purpose in a way. This isn't a small correction. It changes how we think about every cold, hazy world at the edge of our solar system. And maybe about how the raw ingredients of life get built, drift, and settle onto frozen ground 4 billion miles from the sun. Pluto, it turns out, has been quietly running one of the strangest chemical factories we've ever found, and nobody caught it until now. Back in 2017, planetary scientist Shi Zhang at UC Santa Cruz made a prediction his colleagues thought was close to crazy. If Pluto's haze was actually cooling the atmosphere instead of warming it, the haze itself should be glowing faintly in the infrared, visible proof of a radiator effect no one had documented anywhere else. He just needed a telescope powerful enough to catch it. That telescope launched on Christmas Day, 2021. Pluto's atmosphere is almost nothing by Earth standards, thinner than the air atop Everest, made mostly of nitrogen with faint traces of methane and carbon monoxide. Sunlight out there is about 1,000 times weaker than what we get on Earth. Even so, it's enough to kickstart a slow chemical chain reaction, breaking methane apart and building haze particles high above the surface. Think of Pluto's haze less like fog and more like a layer of dark microscopic dust, endlessly forming, drifting and settling. A snow globe that never stops snowing. Scientists had seen a haze like this before, on Saturn's moon Titan. There, similar particles trap heat, insulating the moon and keeping its thick atmosphere warmer than it should be. So when researchers first modeled Pluto, they assumed the haze would do the same thing, but it didn't. Their models kept predicting an atmosphere warmer than what New Horizons had actually measured during its 2015 flyby, by a stubborn, unexplained margin. That should have been a minor mismatch. It wasn't. The gap held steady no matter how the models were adjusted, and it demanded an explanation nobody had. Zhang's answer, back in 2017, was almost the opposite of the accepted idea. What if Pluto's haze wasn't trapping heat at all? What if it was radiating it away? Haze particles absorbing sunlight during the day, then releasing that energy back into space as infrared heat, acting less like a blanket and more like a radiator, bolted to the outside of a building. If true, Pluto's atmosphere should run about 30 degrees Fahrenheit, colder than a heat-trapping model would predict. But the only way to confirm it was to detect the haze's own infrared glow directly, something no instrument on Earth or in orbit could yet resolve. And then in June 2025, James Webb's MIRI instrument finally could. Using the James Webb Space Telescope's mid-infrared imager, researchers separated Pluto's faint glow from its moon, Charon's, for the first time, tracking how that glow shifted as Pluto rotated. Buried in those light curves was exactly the signal Zhang had predicted 8 years earlier. Haze radiating measurable heat straight into space. The paper, published in Nature Astronomy, confirmed it. Pluto's haze functions as a planetary thermostat, dumping heat rather than hoarding it, something never before confirmed on any other world's atmosphere. That should have closed the case entirely. It didn't, because the very process producing that cooling haze was quietly building something else, layer by layer, for 4 billion years. That same faint sunlight doesn't just create haze, it tears methane molecules apart high in Pluto's sky, and the fragments recombine into reddish-brown organic molecules called tholins. Tholins are the same broad class of compounds some researchers think may have helped seed the chemistry that eventually led to life on early Earth. On Pluto, they drift downward in a slow, ceaseless rain, staining the ice a deep rust red wherever they land. 4 billion years of this quiet chemistry is written across Pluto's surface in color. But Pluto is far too cold and far too airless of liquid water, for that chemistry to ever cross the line into life. The ingredients are there. The oven never turns on. And the story doesn't stop at Pluto's surface. Some of that same methane escapes Pluto's weak gravity entirely and gets captured by something 12,000 miles away. Charon, Pluto's largest moon. Charon has its own decades-long polar night, a stretch of darkness so long and so cold that escaped methane simply freezes solid onto its poles. Then radiation and sunlight go to work on it, slowly converting that ice into the same reddish-Tholin compounds, which is why Charon's poles wear a dark red cap visible from Earth. In 2024, James Webb Space Telescope confirmed something else waiting there too. Frozen carbon dioxide and hydrogen peroxide sitting on Charon's surface. Chemical signatures that hint at a moon far more active than anyone assumed for a frozen rock this far from the sun. For years, the story of Pluto was distant, dead, and done. A demoted planet with nothing left to reveal. That is not what the data says. Beneath New Horizons' famous heart-shaped plain of nitrogen ice and past the towering ridges of frozen methane nearby, something doesn't add up. The surface is cracked in patterns that usually mean one thing: expansion, from something pushing outward from below. Scientists think that something is water, not on the surface, buried. An ocean, roughly 100 miles down, kept liquid not by sunlight, but by heat from radioactive decay inside Pluto's rocky core. Two mountains on Pluto's surface look disturbingly like cryovolcanoes, not spewing lava, but slowly oozing icy slush from somewhere deep underneath. A world this cold, this far out, may be quietly hiding a hidden sea. Think about what that means for a second. Pluto sits inside the Kuiper Belt, a ring of icy debris stretching billions of miles past Neptune's orbit. And beyond that, the theorized Oort cloud, a shell of frozen material that may reach nearly halfway to the next star. We've only ever sent one spacecraft close enough to see any of it up close, and no new mission is funded to go back. If a small, dead world like Pluto turns out to be running a radiator atmosphere, manufacturing the building blocks of life, and possibly hiding a buried ocean, then the real question isn't what makes Pluto strange. It's how many other worlds out there, never visited, never photographed up close, are hiding something just as strange. Right now, the only eyes we have on any of it are 1.5 million miles from Earth, pointed outward, waiting for the next glimpse of light from a world we thought we'd already finished exploring.